Hey guys, let's talk a little more about hashing algorithms. A hashing algorithm is a cryptographic function or so-called hash function. It is a mathematical algorithm which helps and maps data of arbitrary size to a specific hash of a fixed size. It is designed to be a one-way function, infeasible to invert back. However, nowadays several hashing algorithms are actually being compromised or have well-known critical vulnerabilities. This happened to the MD5, for example, which is a widely known hash function and has been designed to be a cryptographic hash function. And these days, it is really easy to reverse. That we could only use for verifying data against unintentional corruption. It is easy to figure out what the ideal cryptographic function should look like. First of all, it should be fast to compute the hash value for any kind of data. It should be impossible to regenerate a specific message from its hash value. Brute force attack, of course, should be the only option. It should avoid hash collisions. Each message has its own hash. That means that we can avoid so-called hash collisions or make the same hash for two different messages. Every change to a message, even the smallest one, should actually change the hash value. It should be completely different, and it's called the avalanche effect. What do we use the hash for? The cryptographic hash functions are used everywhere in IT. We can use them for digital signatures, other forms of authentications, message authentication codes or MACs. We can also use them for indexing data in hash tables, fingerprinting, identifying files, or just detecting duplicates. We can detect if a sent file didn't suffer accidental or intentional data corruption using a hash function. Moving forward, let's look at a specific example here. How does the hash works? Really simple. We're sending a file to our friend. It's a really important file, and we want to ensure it has been received in one piece. That's when our hashing algorithm comes in. But first, let's think how our file will transfer we can figure out some trivial ideas, but you could, for instance, call user number 2 and you could check the file content together. But then what's the point in sending a file this way? Checksums are our best bet here. So what is a checksum? Before sending a file, user 1 uses a hashing algorithm to generate the so-called checksum for a specific file. Then he or she sends it along the file itself. And user number 2 receives both the file and the checksum. Now he or she can use the same hashing algorithm on the received file. What's the point here? We already know that a hash is individual. So there can be any other file with the same hash. Of course, so if the file we hashed and we sent to the user number 2 is the same and it's untampered, when user number 2 makes hash using the same algorithm on that same file, both hashes or checksums should look absolutely the same. This is how we check the integrity of a file here. Popular hashing algorithms moving forward will be, of course, the MD5, which nowadays is completely broken, but for some time MD5 was really widely known and used. It was used for many years and unfortunately is still widely used, but despite initially being designed to be used as a cryptographic algorithm, actually these days you can use it just to check the integrity of a specific file. We already know that the secure hashing algorithm can allow collisions, and in MD5 it's fairly easy to manipulate a document by injecting a malicious code while still getting the same hash. So as you see, we cannot use it for integrity as well, which is really sad. But this is just so you know what's vulnerable, what not to use these days. We can say that one of the things that killed MD5 was actually its popularity. So it became a huge target for attackers. It was used so much that the best tool for cracking MD5 hashes is now Google. So you can decrypt everything that's hashed in MD5 just by Googling and using some online tools. Typing the hash in the box, you receive it before state within milliseconds. So this is really sad, but this is a fact right there. You could think you're secure if your passwords are not stored as MD5 hashes, but if somebody gets access to your database, he or she can just type the hash to Google and get its real value. If you want to know more about hashing passwords and its security, you should definitely look deeper and see how you can store your passwords securely. These days, the so-called rainbow tables or huge dictionaries databases with hashes are used to compare with the given hash, and this way find the input before the hash goes out, so the initial plain text. Next one that we're gonna be using yet is the SHA, and it's a whole family of things. Secure hash algorithm, or so-called SHA, is a cryptographic hash function designed by the United States NSA, which should be pretty secure as you would think. SHA-0, published in 1993, has been compromised many years ago, unfortunately. The SHA-1 1995, it was produced back then, and it produces 160-bit or 20-byte hash value. This is typically rendered as a 40 digits long hexadecimal number. This one, of course, has been compromised in 2005, so you can see a pattern here. Something comes out, a few years later, it's officially compromised, but in reality, it has been compromised way earlier than that. It's just officially announced that year. Think of how many things you can do if you manage to compromise hash algorithm, and why do you want anyone else to know about it if you can do all kinds of things, make profit, and being a black hat here, or just criminals, cyber criminals, all that. So the best bet here is to have a white hat, or just a person that's unrelated to criminal world, find out first how to break this and announce it out to public. But usually criminals are doing this prior to anyone else, because they're investing a lot of financial, manpower, resource in order to break the security, the newest security concepts and systems. So in 2005, they found a theoretical collision, but the real death of the SHA-1 occurred in 2010, when many organizations started to recommend the actual replacement of it. The big three, Microsoft, Google, and Mozilla, have stopped accepting SHA-1 SSL certificates in 2017 on their browsers after multiple successful attacks. So you see how later they actually stopped accepting such algorithm. So 2010, the organization started recommending replacement, and in 2017, the browser stopped accepting it. So imagine how many successful attacks happened throughout this time frame. SHA-1 was built on principles similar to those used in the MD4 and MD5. It has a more conservative approach, though, so the safer option will be the SHA-2 or SHA-2, which includes several important changes. Its family has 6 hash functions with digests. So we have the SHA-224, SHA-256, or 512 bits, which are the SHA-224, SHA-256, SHA-384, 512, or the 512-224 with a slash, or 512/256. So here we have huge family of the SHA-2 hashing algorithm. There are numerous reasons why you should move to SHA-2, but as bottom line, SHA-2 is a lot more complicated and is still considered safe. However, SHA-2 shares the same structure and mathematical operations as its predecessor, SHA-1. So it's likely that it will be compromised in the near future. So or it has been already compromised, but no one knows about it officially. A new option for the future would be the SHA-3. SHA-3 secure hash algorithm 3, designed by Guido Bertoni, Juan Diemen, Michael Peters, and Gilles van Asch. Their algorithm Ketchak won the NIST contest in 2009. which is pretty awesome and has been adopted as an official SHA algorithm. It was actually released by NIST on August 5th, 2015. One of SHA-3's requirements was to be resilient to potential attacks that could compromise SHA-2. So here people are trying to stay ahead of it and create new standard before the old one is officially compromised. Here I would suspect that someone found something that actually made the SHA-2 look bad and unsecure. That's why they forced this SHA-3 standard. So the Keccak is significantly faster than SHA-2, from 25% to 80% faster depending on the implementation. It uses the sponge construction. The data is first absorbed into the sponge and the result is squeezed out. So while absorbing it, message blocks are explored into subset of the state. Then it's transformed as one element, while squeezing output blocks are read from this element, but alternated with state transformations. Really here, a key aspect of the SHA-3 is that it was designed to easily replace SHA-2 in applications that currently use SHA-2 option. As so, the transition from SHA-2 to SHA-3 should be analyzed in regards to the required security level and the overhead. Everything would need testing, of course, but that greatly depend on the application structure and architecture. SHA-3 authors have proposed additional features like authenticated encryption system, which also the three hashing scheme, but this hasn't been standardized yet. It's the safest hashing algorithm for now, but I would bet not for long. As you would think, trying it, testing it will be a good option here because it's something that will be implemented in the next few years and it will become a must. So staying on top of it, ahead of the game, you can try to implement it in a testing environment, see how it works, maybe try to test it in order to find some vulnerabilities in it if you have some time. It's really a lot of reading, a lot of understanding, maybe trying to be innovative and find something that people has not think of yet. This is a kind of a bigger project which can bring a lot of value to your ethical hacking skills. Understanding of encryption, cryptographic algorithms, and hashing is something really crucial because every time, most of the times, let's say 99% of the times, it will come to that. So you find something, you find a hashed password, you find encrypted communication, maybe you have to do something about it. Maybe it says it has it's using a weak algorithm, a weak cipher, but again, if you don't know how it works and how to break it, this will be a blocker for you. Another important hashing algorithms will be the one used to store Windows passwords. We're talking about LM, NTLM, NTOM version 2 hashing algorithms. When attacking the Active Directory, passwords are stored and sent in different ways depending on both age of the domain and where you find it. Most of these hashes are confusingly named, and both the name of the hash and the authentication protocol is named almost the same thing. Starting with LM hashes as the oldest password storage used by Windows, dating back to OS 2 in 1980s. The limited char set allowed, they are fairly easy to crack, unfortunately. You can obtain them, if still available, from the SAM database on a Windows system or the NTDS database on a domain controller. LM hashing algorithm was turned off by default starting in Windows Vista Server 2008. And when dumping the SAM database that stores all passwords on a Windows machine, they are shown together with the NT hash before the colon. So it is really possible to enable the LM hash in the later versions through a GPO setting. And it's even possible to do it in Windows 10, which is interesting, of course. I won't do that. The NT hash, or so-called NTLM, is the way passwords are stored on modern Windows systems and can be obtained by dumping the SAM database or just using Mimikatz. They're also stored on domain controllers in the NTDS file. These are actually hashes that you can use in order to pass the hash. You can find a little more about this type of attack and basically breaking Windows authentication, other materials, or just research it online, play with it. It's really common thing to do. You need the NTLM hash value in order to do that for Windows systems. Usually people call the NTLM hash which is a little misleading in my opinion, as Microsoft refers to this as the NT hash. So you can use both ways. Me personally, I use NTLM or NT hash. Definitely the goal here is just to avoid confusions, know about the two options. The NTLM version 1 or net-NTLM version 1 is another protocol uses use NT-hash in a challenge response type of deal between a server and a client. The version 1 of the protocol uses both NT and LM hash and actually depends on configuration and what is available. A way of obtaining a response in order to crack from a client responder is a great tool that I would recommend here. These days the version 1 is deprecated and you can actually use the NTLM version 2. This is an improved version of the NTLM protocol, which makes it a bit harder to crack, of course, but not impossible. The step here is the same as the NTLM version 1, the only different algorithm and responses sent to the server. So this is the only different thing, is the algorithm and the responses. Also captured through responder tool or something similar. This is a default algorithm in Windows since Windows 2000. Since the 2000 Windows. And in summary here, for those NTLM hashes, I would say that this is where Windows stores passwords, and it thus is pretty popular. NT is also known as NTLM, and of course can be cracked to gain password, or it could be used to pass the hash and compromising of sensitive information, of full system compromise, so on and so forth. NTLM version 1, version 2 are challenge response protocols, and they're used for authentication in Windows environments. And they are using the anti-hash in the algorithm. And that means that it could be used to recover the password through brute force dictionary attacks. They can also, and they can also be used in a relay attack. Of course, if you're still confused, you can read a little more about it. Definitely, I recommend going for testing it, and do it on your test environment. Go ahead, try to pass the hash. There's some online labs, or you can set it yourself. So this is a good way to go. In conclusion, I can say that hashing algorithms can be really, really useful. However, it is a really fast industry, fast growing, really dynamic environment, and also extends to the hashing algorithms. MD5, once considered really safe, now it's completely compromised. So think about this when you're implementing something. Think about, yeah, I'll need to upgrade it in a few years. This is not 100% security, as this such thing does not exist like 100% security. Then there was a SHA-1, of course, it's now unsafe, and the same thing happened to SHA-2. So yeah, it's a pattern here. You have to really think about it. In order to keep your security standards, you should always follow the newest technologies. So just stick to what's up to date right now, the newest version, especially when you use hashing algorithms for security. Definitely a good idea to do that. The application security should never be dismissed, as it can make or break your business, as you see. So definitely everywhere where you're using hashing algorithms, you should be careful and think of second security control, not relying only on hashing. Many developers, in my experience, have told me that, yeah, this is hashed, so it's secured, everything is fine. But as you can see, using old algorithms, or maybe they hash it with MD5 and they kind of feel, okay, it doesn't look like plain text password, so it's secured. But there is always an option. Unfortunately, attackers these days are very, very, very creative, as we always say, they have the more resources than us, they have more time, and this makes our job as security professionals or just IT guys very, very hard. In order to stay on top of the game, I would recommend applying hashing as part of your complex security system, and in the same time think of other layers, multiple factor security. So we rely on encryption algorithms, we rely on hashing, we rely on, of course, strong passwords, firewalls, intrusion prevention systems. Uh, we should rely on training employees, regular training, testing them, making sure everything, as far as most common social engineering techniques, are well known by all the employees, no matter their occupation, no matter what area are they working in. It's just everyone becomes target these days, and it's really easy to send out phishing emails, and trick someone to click on a link or download a file. People are becoming more cautious about it since a lot of them or their friends, family have been compromised and hacked throughout the years. But that's not the only way. Like, you need to be thinking about your security even before you're being hacked. So stay safe and really try to understand and test, play with different hashing algorithms, and maybe someday you'll be able to create your own hashing algorithm, which will be, you and your friends might be winning a contest like those guys with the SHA-3, so your algorithm can become a standard for everyone, which sounds pretty cool to me. So stay on top of the game, guys. Thank you for watching. Stay tuned with our next video.